5 just years.
You in general, but. Can you put this inside of my backpack?
Okay.
Get back at like 12.
I like how they crammed all of first band onto one bus,
They
one
did for
school
us,
bus.
too.
Huh?
It did for us too.
Oh, I forgot you're not first. Huh? Yeah, they like crammed everything and like the Suses too, and
Yeah.
it was humid.
Also, whenever we first left, someone didn't close like the storage underneath. So someone like heard it on the latch. So I think we're all scared for a
Oh,
second.
that's Christians.
Mm-mm.
Mr. Thompson, I won't be off.
That is such a bazinga moment.
Huh?
I won't be here on Friday.
Okay, there will be a
Bazinga,
reviewer sheet.
bazinga.
I don't have it printed out yet, but it's on the website.
3 raisins.
Are you gonna be here tomorrow?
Test next period.
Good, swing by during the time.
Acts 2 and 3.
Oh, we have school business at 1:45.
Do what?
We have school business at 1:45.
What's up, girl?
What do, baby?
Why are we doing
Oh, because it's formula, it's like your formula. Took me a while to get that one.
That is such a neat slapper.
I was like,
You can find your own memes.
I don't know.
I'll make that.
Might make some. I don't know. Are we just starting like the algebra 2 stuff?
This is stuff that you did in Algebra 2, yes, but you probably spent 2 weeks on all of this, whereas we spent 1 day, because you should remember some of it. They don't have school business marked yet, so just make sure they update it at some point, because I
They
can't.
just told us.
I know, but I'm just saying, I can't change it to school business, so they'll have to. That's all.
He finished it for once, twice. He's run twice now.
That is
I actually have my tips in my bag.
He's feeling a bit up.
Is it baseball?
Get it managed.
Why did you go to Irish?
No.
Seasons. Spanish?
What's your baby for
Bazinga. What?
Did you get it on formula?
I didn't even read it.
Just say spaghetti to it.
Hey, it's Wednesday.
Larson, is the author of this book.
Yo, it's hump day.
You would say that.
Brain knows.
My vision, I see my friend that tried watching this, but
What
it's
this?
not near what she said.
Hump day. No, not that brain.
I couldn't even help it.
No, it's another.
That was really
Camera?
hard. And then I like started like I couldn't focus.
That's the big one.
You know.
I don't know.
No, the yo, it's hump day. Here's this for free. I thought you were part of the sub community.
I know what you're saying. Wasn't it 3? Yeah. Have you seen the one with Mark? Dude, look that up. Where is the original from?
Sit down.
Like Ben, you don't recognize this guy?
Is Diego gonna be tardy?
Huh?
I said, is Diego gonna be tardy?
What? What are you talking about?
Mark
No, I've
Thompson
seen
tardy.
that one, but
He's not here, he's absent. Okay, he is tardy.
Are you counting me as tardy?
Are you late?
I was helping out clean up a mess.
You shouldn't have said anything, Thompson.
Where?
Student council
For who?
and Coach High's room.
That sounds like y'all planned it. It sounds like you were cleaning up your own mess.
No, she was giving blood, so she couldn't clean up her mess.
Oh,
So we cleaned it up for her. Huh?
So funny.
She made a muss with her blood. So like expressive.
What?
Like,
There was blood all
No,
over
no, no. She was giving blood. I also have to leave.
All right, first thing, if you did not turn in 105, I opened that up in Google Classroom the other day. Some of you already turned that in, but if you didn't, that was the assignment from last class. I need that with your name on it. If you would please come turn that in. And then today's handout is 106, where we're going to do some more with quadratics. But instead of just looking at solving, we're going to look at some other stuff, mostly graphing stuff. And you can see that your handout today is very short. So for you to get some practice, I've got it's like 15 book questions, I think. So that will be our class period today. So get 105 turned in, please. Number 106. And then join us up here. So 106 is a bunch of questions about this quadratic. But all these questions on the top half are the same as the questions on the bottom half. The only difference is it's a different quadratic function. So like all of our algebra review, ideally you remember all of this and you just basically have to participate and practice a couple and you're done. But realistically, you guys haven't used this stuff in a year or a little bit more than a year, some of it. So it's important that you mark up and identify the stuff that you need to study. Now, part of what can make this challenging is you guys might choose to tackle some of these questions in a different order than I would. There's not like one right way to do it. But what I would tell you is that we're going to look at these in 3 different forms, and each one of these forms has their own kind of strengths. So specifically, this one, which I will call standard form. Standard form, the name standard form can change depending on which textbook you read. Our textbook actually calls vertex form standard form, but I'll help you with that later. If I want to find y-intercept, standard form is great because y-intercepts always have an x value of 0. Plug in 0, you get 0 minus 0 minus 12. If all you care about is y-intercept, then standard form is about as easy as it gets. But sometimes factored form is going to be better. So as its name implies, factored form means you should factor this. So all of these have a factor of 2, so you should always try to factor out the greatest common factor first. And then you can factor your trinomial with guess and check, product sum, any method that you need to, but make sure that you factor it correctly. So that one's fairly intuitive, factored form. Now, to me, factored form helps a lot with x-intercepts, because if x-intercepts are when y is 0, we can plug in 0 for y here, and this is basically what we practiced last class, except that it's already factored. So you can set this factor equal to 0 and solve, except 2 never equals 0. You can set this factor equal to 0 and solve to get 3, and you can set this factor equal to 0 and solve, and you get negative 2. So factored form is probably the easiest way to get the x-intercepts. A lot of these other questions are going to come from what's called vertex form. And unfortunately, this is probably the one you're least familiar with, so it will take the most amount of review. But for vertex form, and your book, by the way, calls this standard form. Bless you. First off, you have to know what your answer is supposed to look like. That is vertex form. And within that, there is 3 numbers that you need to change. A, H, and K. So to be able to do vertex form, you have to know where those numbers come from. So A is the easy one. A is the same as this A. The same A you use for quadratic formula, that's why they use the letter A, so that you know that it's all the same thing. So for us in this question, A has to be 2. And H, K, if you pair those up as a point, this gives you the vertex, which is why a lot of people call it vertex form, even though your book's going to call it standard form. Well, there's two ways you can go about finding h. So I'm going to come back to the second method here after we start our graph. But one method that we're going to use right away is h is negative b over 2a. Does that sound familiar? Where have you seen that before?
Unit circle things. Shenanigans.
Not outside Algebra 2. When have you seen this in this class?
Quadratic formula.
Very good. It's the far left part of quadratic formula. This part of quadratic formula gives you the x value of where the vertex should be. So, be careful with the arithmetic. I made this mistake first period today. Opposite of b would be 2. Divided by 2 times 2 would be 4. So 2 over 4 makes 1/2. H is 1/2. So you're supposed to do x minus what h is. So minus 1/2. The y value, k, comes from, like any other point, if you have the x value of the point, plug it into the function and solve for y. So 2 times 1/2 squared minus 2 times 1/2 minus 12. I'm just plugging that in here. We would get negative 13 plus 1/2, which would be negative 12.5. So a is the same a from quadratic formula. H, you can use this formula, negative b over 2a. And k, just like any other point, the vertex is not special in this regard. Plug in the x value of the vertex into the function and solve for the y value. A, h, and k. That is the vertex form. Oh, sorry. But if you have vertex form, answering some of these should now be pretty quick, because this is, if you take the opposite of this positive 1/2, and pair it up with not opposite of this, that's where the vertex would be. So it's kind of like in linear equations, slope-intercept. You can look at the equation and basically instantly see the slope and the y-intercept. Point-slope, you can look at the equation and instantly see a point that the line goes through and the slope of the equation. Vertex form, you should instantly be able to see the vertex. Opposite of this paired up with not opposite of that. Yes?
Did you plug in the point on K?
Did I plug in what?
Like a point, like the y, the vertex intercept, is that what you did?
I took the x value of the vertex that I got from negative b over 2a. That told me the x value of the vertex was positive 1/2. I plugged that into the function to find the point, and that gave me the y value. Okay, out to the side, if you don't remember this, how to know if this parabola is going to open upwards or downwards is based on this a value. If a is positive, your parabola opens up, and your vertex would be a min, like this question. But I think on the next one, a is negative, which means your parabola has been flipped over the x-axis at some point, which means your vertex would be a max. And if you have the vertex, you already know what the max or min is. So not 1/2. 1/2 is when it has a max or min. Negative 12.5 is what the minimum value is. You want the y value there, not the x value. Okay, let's start to look at the graph, because then I think the line of symmetry and this vertex will make a little bit more sense. Now, if this goes all the way down to negative 12.5, I don't think you can center this like in the graph. So you might want to do something like that. Yours doesn't have to be exactly block for block the same as mine. Just try to be close. But let's go ahead and plot the y-intercept. Plot the vertex. the x-intercepts, and then we can talk about this line of symmetry. Line of symmetry, also known as axis of symmetry, can be asked both ways. It's the vertical line that splits your parabola in half. And for it to split your parabola in half, it has to go through the vertex. So since it's a vertical line, our equation should be x equals a number, and to go through the vertex, we need it to be x equals 1/2. Now, even if you're not asked about the line of symmetry, it's nice to think about it because you can see how this point flips over, and also this point could flip over, get you a 5th point, and with 5 points, you've got a pretty good looking graph without a calculator. Now, I did say earlier that I would give you a second method to find the x value of the vertex. So this is good for a backup. So the first time I got it was negative b over 2a, doing arithmetic. But do you see how if these x-intercepts are supposed to be equidistant from the line of symmetry, what number is in between -2 and 3? 1/2. So if you know the x-intercepts already, then the line of symmetry has to be going directly in the middle of those, and that line of symmetry has to be going through the vertex. So that's a second way you can find the x value of the vertex. The y value still has to be found the same way. You have to plug in this into the function and solve for y. Okay, that's the hardest part, because then increasing, decreasing, and constant is just a matter of looking at the graph and knowing what they're asking for. Increasing is about where it's going up. He starts going up at 1/2 and then goes up forever to the right. Decreasing is about where he's going down. He starts going down from the far left and continues to go down to 1/2. Now notice on these two, I'm not describing how far up it goes or how far down it goes. I'm describing when it's going up and when it's going down. So these are asking you to describe x values. And for those of you interested, in calculus we do this in calculus as well, but in calculus we figure out the same thing without the graph. We use some calculus to figure out when it's increasing and decreasing. So. Alright, and then constant is when your graph is flat, and a parabola, I mean, it's technically flat at this one little instant right here, but not for any given amount of time. So we're just going to say none or not applicable. Not going to leave it blank because then it looks like we don't know. Yes, Diego?
So you said that the vertex was HK, right? But,
Correct.
like, you wrote it as like negative HK, like in like the actual vertex point.
Are you talking about this?
Yeah, like
And that's because this is the way the form is set up. You're supposed to subtract the h value and add the k value. So if you're looking at this, trying to see the vertex, you have to take the opposite of this because you're really subtracting what h is. That's where a positive one happens.
oh, so
And you don't take the opposite of that.
so you just ignore the sign for.
Well, you need the opposite sign. If it's plus, this would be negative. If it was minus, then this is positive. This one is opposite of what it looks like. Because of the way this form is set up. You subtract h, but you add k. That's why one of those looks backwards. The one nice thing is, obviously, like, nobody's thrilled to answer 50 different things about one quadratic. But when you do, all of this stuff needs to be consistent. If one or two of these things are wrong, your graph, that stuff's going to kind of stick out because it's going to be so inconsistent with everything else that you saw. Okay, let's look at this one more time. Most of this is still the same, but hearing it a second time before you try to practice it in the book. So again, you could really jump around and do this in any order that you think makes this the easiest, but I'm going to point out that What I call standard form is great for y-intercept. Plugging in 0 for x is very quick to solve for y. I'm going to go ahead and plot the point while I'm at it. If you're asked for factored form, that means factor it. Now you don't have to factor out the negative, but I would recommend it. And the nice thing about factored form is you're trying to figure out where y equals 0 for x-intercepts. You can set -1 equal to 0, and that's never true. You can set x minus 4 equal to 0 and solve. And you can set x plus 2 equal to 0 and solve. So factored form is great if you want x-intercepts. Now, I'm going to go in kind of a slightly different order here, just to help you see that you can approach some of these in a different way. If there's one x-intercept at -4 and +4 and -2, what number is in between those two?
Say positive 4.
+4 and -2 would be 1. So do you see how this is exactly in the middle of those two x-intercepts? That means that is your line of symmetry, x equals 1. That's the line that's supposed to cut your graph in half. And so you can actually use that as a little bit of a cheat to know that the vertex has to have an x value of 1, because it has to go through the vertex. And or you could say h, which is the x value of the vertex, is -b over 2 times a. You can also solve for it that way, but you have to remember that formula to do it that way. Okay, and then how did we find k? Right, so plug the x value of the vertex into the function and solve for y. That would be k, which is the y value of the vertex. Looks like it should be 9. Okay, and if you're asked in the textbook, it'll say standard form, but when you in here you're asked for vertex form, you have to know what it's supposed to look like. You have to know a is the same as this a. You have to know h comes from the x value of the vertex and k comes from the y value of the vertex. That is usually one of the harder things for students. I don't know if y'all just don't practice that as much in Algebra 2, but it is something you need to know. So out of all of this, what do you think students usually forget the most?
The questions on the side, or how to do what we just did.
Like if you knew what the right answer was and you wrote it down, but you wrote it down wrong.
Oh, yeah. Pulling the h out correctly.
Actually, no. It's this. A lot of times you guys don't write the squared on there, which doesn't even make it a quadratic. So make sure you have an exponent of 2. Just very easy to forget. Okay, to know if the vertex is a max or min, like we looked at above, if a is negative, your parabola is going to open down, which is going to make your vertex a max. And that max value is the y value of the vertex. See, I can plot that on my graph. I didn't plot the vertex. Because of this line of symmetry, any point on the left side can flip over and give us a point on the right side. So this point could flip over and get us a 5th point. And then we can connect those and call that good. And then where does it look like the graph is increasing?
Negative infinity to 1.
Good. You're looking at x values when it's increasing, not what it's increasing to, but when it's increasing. Decreasing would be good, 1, and then forever to the right. And constant is when the graph is flat, not flat. No flat times, other than this one instant, which is kind of true. But okay, anything that immediately jumps out at you from this handout? Okay, then on a separate sheet of paper, go ahead and copy those questions down and start them and see how it goes. I will check back in with you in 10 or 15 minutes and offer some help.
Wait. So you do 5 through 8, but for 51 through 59 you do 51, 53, 55, all those things.
What day is the 9th? Oh, yeah, that's one.
Monday?
It's next Wednesday. Yeah, so Wednesday, this is the last of the new stuff before your next test.
Huh?
This is the last of the new stuff before your next test.
Which is
Friday, we will do a review. Christian, sit down.
Oh, sorry.
Sit down.
Sorry, I was grabbing textbooks.
Okay.
so it's
And
next
then
Wednesday.
2 minutes. Sit down.
Sorry. What was that?
Thank you.
The test is next Wednesday.
It is. Friday will be a review. Monday is ACT Aspire.
Ugh.
And then, so it doesn't, we can't do it then. So it'll be Wednesday.
What ACT things do we have to do?
I feel like.
Are you a 10th grader?
Yeah.
What?
You have to do all 4 of them.
What?
2 of them,
Oh, wait, no, that's maps testing. My bad.
there's like 2 of them on Monday and 2 on Wednesday, I think, or Tuesday.
That's probably.
I heard something about Friday off or something. I don't get what that is.
You have to turn your makeup on.
Maybe I'm stupid.
Okay, none of that stuff is important right now. Y'all need to move on to your homework. If this is too much time, we can make it due at the end of class. That's perfectly fine with me. If y'all don't, I'm not gonna go out of my way to not give you homework if you're not gonna try to get it done in class.
Okay, that's not too many.
It's not if you get started. If you waste 10 more minutes, it is.
What?
said which, how do they word it differently? What standard?
What the book calls standard is really vertex, which isn't that important until you go to check some of your answers in the back. Haley, do y'all need to move or what?
No, sorry.
I'm going to get blood. I should probably be back before
Okay.
class, but
They've got you marked as school business, or are they
Uh,
gonna mark it later?
I'm not sure. I don't think they mark.
Okay, then you need to bring back a pass or something.
Okay, yes sir.
Okay, it has been 10 minutes, so maybe questions from the first 5? Any of those that you struggled with that you need some help on? Make sure you guys are checking your answers either on a calculator or in the back of the book. Don't just assume it's correct. Okay. I will check back in another 10 minutes or so. What time did you say baseball needs to leave?
I don't know if we leave it off.
Oh, okay. Let me check teacher announcements. I thought you knew.
When he sent a text, it said 1:45, but he hasn't put anything in.
Well, he might put in the school business later, which is fine. I just let you know that I can't change it to school business is all.
It's past 1:45 if y'all need to go. Who are y'all playing today?
Harvard.
I suspect they're pretty good.
They beat us yesterday.
Well, you better steal some bases.
Yeah. Strike them out.
It's yesterday. Oh, you did? I walled you.
One inning, one strikeout, no runs.
Better than anything else, yes.
All right, it has been 11 more minutes. So, questions from maybe the first 10 in the book assignment? What you got?
I'm confused what we're supposed to do for 51 through 55.
They want you to graph it in your calculator, look at the x-intercepts, and then on your paper solve it algebraically and see that they're the same thing.
For which one?
Starting with 51. No other questions within the first 10?
Oh, walking through, 39 or 41.
Okay, let's look at 39. Well, if they give you vertex, that's a hint that probably should start off in vertex form.
Well, I figured that out, but I don't know how to do where, I don't know how to find A.
Okay. Let's see. Okay, well, if they give you vertex form, then they're giving you H and K. So we can go to vertex form, which is what your book calls standard form, and plug in 1 for H and -2 for K. Remember, this one looks opposite of what it's supposed to be, and this one does not look opposite of what it's supposed to be. So you got that far? Okay, so then yes, your issue then is trying to figure out what is A. So what you can do is you can temporarily use another point for Y and X. Plug in -1 for X, plug in 14 for Y. And do you see how that gives us an equation we can solve for A now? So this would be -2 squared would be 4. Add the 2 over, divide both sides by 4. It looks like A is 4. And then we can just go and throw that back up here now that we know what A is. And then there's the equation you need.
Thank you, sir.
Okay, and then 41 looks like the same type, so you need to try it before we do it up here. Okay, let me set another timer, maybe the last one, depending on how close to the end you'll get, in another 10 minutes.
Thank you.
square root is called the determinant. If the determinant's ever negative, you know you have no x-axis. Because it's an imaginary number, it doesn't show up on the x-axis. So.
Not too much of a random imaginary x.
let's check. Alright, so it's been another 10 minutes. Y'all found any others I can help with? Okay, I'll check back in one more time. Y'all should be in near the end of the assignment here, and you got 25 minutes left, so. But I can check in one more time and still have time to take your questions.
answer or ask questions, Gil?
Been 10 minutes by 8 seconds, so now would be a good time. What you got?
73. But I understood it until I looked. It doesn't make sense.
73 is definitely one of my favorite question types. Rancher has 200 feet of fencing to enclose 2 adjacent rectangular corrals. See figure. So 2 rectangles, and he's got 200 feet of fencing. So pretty realistic, because it looks like he might just want to keep a couple of his animal types separated there. Okay, write the area A of the corrals as a function of x. So in the picture here, they're asking us to think of this length as x. So that length is x. And they're saying this length is y. So area for part A, for this type of shape, well, what type of shape is this? Okay, and what's the area of a rectangle formula?
Base times height.
Okay. I'd say length times width, but same thing.
Okay.
What is the base? See why that's 2x? Okay, what's the height?
Y.
Okay, but this question says as a function of x. So right now we have it as a function of x's and y's. So we've got to somehow change this y into the equivalent x's. So if we use this 200 feet, you've got 200 feet of fencing. Well, how many lengths of x are we going to have if we build this fence?
4.
Good. This would be an x and this would be an x, so there would be 4 x's. And how many y's would we have?
2.
That's it? Y, y? I thought we were splitting this up.
Oh, 2.
There's 3 y's, because we're trying to divide this up into 2 different pins. So from this, we could subtract the x's over. We could divide both sides by 3. And then now you know what y is. So instead of calling it y, we can call it 200 thirds minus 4 thirds x. And it's kind of messy, but that would be a good first answer, because now that is area as a function of x, not as a function of x and y. And then what dimensions produce a max enclosed area? Well, if, this would be kind of messy, but if we multiplied this stuff together, you would get a quadratic. And if you rearrange that stuff so that it was in standard form, you could go about finding the vertex. H would be negative b over 2a. K would come from plugging that x value into the function. But to me, it kind of makes sense to just go ahead and use our calculator here. Let's see what it looks like. So we had 2x times, you've got to tell me what the rest of it was.
200 over 3 minus 200.
I just misclicked.
Minus 4 over 3x.
Okay, and I'm probably not going to get to see much of the graph here. You can see it barely starts to go here. In fact, if you're using a non-color calculator, you probably wouldn't even notice that. So we either have to do one of two things. We can either change these window settings, and we have to guess and check till we can kind of see what's going on. Like going up to 10 is not enough. Let's maybe try 100. I can kind of start to see my parabola. So I can go ahead and keep guessing and checking like this. There's nothing wrong with this. This is a good skill to have. But another thing that you guys may not know of that's also good to try, if you hit Zoom, have you ever tried Zoom Fit before? Zoom Fit is where your calculator tries to guess what it thinks you might be interested in. And it doesn't usually do a great job, but it usually gets it pretty close. So like right here, it looks like I want to see a little bit higher up and more to the right. So more to the right, increase X max, higher up. So again, it might have taken me a while to get to that value. And honestly, I don't care about that. So let's just make that 0. Okay, that's enough of my parabola. You can see that this is the area. Area gets bigger as X gets bigger, and then eventually, if X gets too big, you see how the area starts going back down? So the max area is right here. That's what we're visualizing. And if we do second trace, calculate maximum, our calculator will do this for us, but we need to make sure our cursor's to the left of it before you hit enter on left bound. Move your cursor to the right of the maximum before you hit enter for right bound. And if you want to speed the process up, you can try to put in a guess. And notice our calculator has a little bit of rounding error, but it looks like the max area would be when X is 25, you would have a max area of 1,666 2/3. So, very good example of showing you where you would maybe care to know about a vertex. A real life example of where a vertex would be beneficial to find, not just generic. Is that enough for that one?
Yes.
Okay. All right. Somebody else got maybe one more. Have to be a little bit quicker than that one, but. Okay. Then you guys got about 5 more minutes here, so maybe try to finish up one more question. If you don't have those finished, I need you to, oh, that was the last one of those. If you don't have those finished, I need you to finish practicing the rest of them. I'll give you one more chance to ask questions near the end of this assignment, just in case you didn't have time to ask today. I will do that on Friday. Also on Friday, there'll be a review worksheet where I remind you of the stuff that'll be on this unit test, some linear stuff, some piecewise like we did the first day, solving quadratics like the last class, and then graphing quadratics like this class. And then that would put us on track to have the test next Monday. But next Monday is ACT Aspire, and so I will only see y'all in the afternoon for like 10 or 15 minutes. So obviously we can't do the test in that amount of time. So that puts our next test this time next week on Wednesday. It should be in your student announcements. I mean, I have it, but I don't have a hard copy. I just have it in my email.